Hello everyone, and today we will be solving this. What are we solving? That is, we are going to find the intervals of the convergence and its radius of this. Let's get started by using the roots test, which if we do, we get as limit as n approaches to infinity, we have a absolute value of x to the power of n over square root of n, and then we have a square root of n onto this. Okay, and then more simplified problem we would get is that the square root of n, and that just n times 1 over n, that's just 1, so that just leaves us with this over, that is a n to the power of 1 over 2, and then a times 1 over n. But this is the same thing as this, just switched the orders of them. And on previous videos ago, I have mentioned that as limit of n approaches to infinity of n to the power of 1 over n, that is equal to 1. And that's just 1 to the power of 1 over 2, so that's just 1, so we don't even need the fractions. The only thing we have is just this. Okay, that's very nice. But, okay, yeah. And now we have this now, which is also equal to this. Okay, and the radius is 1. Very simple, but the last thing we are trying to solve is the intervals of the convergence. Okay, when does it converge at each specific intervals? We need to determine if this sign has a line underneath it, or this sign has a line underneath it, or both could not. One way to tell is that if there's a line, that means it's convergence for when x is minus 1, and if there's a line here, that means it converges when x is 1. But when there's no line, that's just diverge. Okay, so let's put in the x is equal to minus 1 into our original set. Okay, that's just when x is equal to minus 1, and then when x is equal to 1, we have this. Okay. Let's start off with a simple one. This is a diverge because no matter what the value of n is, the numerator is always 1, and that's just 1 over square root of n. And from the, I don't know what that was, but yeah. From the p series, okay, the p is equal to 1/2, okay, and 1/2 is smaller than 1, making this diverge, okay? So this whole thing is diverge. So we have decided that right here, it needs a no line, okay? It just stays like this. X is smaller than 1, no equal to. Okay, with this one, we can use the alternating series test. Okay, so alternating series test. And if we do apply it onto there, we get converge. Okay, we get converge, so which means there is a line underneath this sign. Very nice.